Hello everyone, let's try to solve the previous year questions from this chapter, alcohols, phenols and ethers. Mostly I'll be covering the question which came in 2021. Okay, so let's try to solve one by one. And before getting into solving, just try to pause the video and try it by your own and then watch the video. Okay, and if you think this video is somewhat slow, and you can just switch into 2x speed and then you can watch this video. Okay, first try to solve by your own and then see the solution. Okay, let's try to solve the first question. They are asking the final major product they are asking, so we need to find the major product over here. So it is simply dehydration reaction only. So what happens over here, let me draw it over here again. So here they have given HCl, right? First, whenever there is a OH and it is occurring in the presence of an acidic medium, then there will be protonation. Okay. First, what happens here? Protonation of OH group occurs. Means it these lone pairs try to obstruct the H plus. Okay, H plus Cl negative, and here it will form this. Here it will form OH2. I mean H2O only. So H2O is a good leaving group, right? So whenever we do the protonation, that is why we are doing it, because as water is good leaving group, it leaves easily. So this will leave easily as a water, and here it will form a carbocation. Okay, here it will form a carbocation. One more thing here, important concept is that here the carbon is secondary, right? As we know that carbocation ka stability is tertiary is greater than secondary is greater than primary, right? So here you can watch one. I mean here you can see one. You can see one hydrogen, right? This hydride shift takes place over here, and the positive charge will get over on this carbon, so that it will be tertiary, and here we'll get this. We'll get the positive charge on this particular carbon. Now this chlorine, Cl negative, act like a nucleophile and it will attack on this particular carbon. Okay, then finally the major product will get this one. Here it is chlorine. And see, one more thing is that, see here, this is a major product, and we might get minor product here itself, because this chlorine Cl negative might attack over on this particular carbocation and it might form this compound. Here it is this will be major, I mean sorry, this will be minor. So as they are asking major product, this will be the answer. Okay, so I hope you have understood. First, what we have done, first step is protonation, and then water leaves as a living group and it forms a carbocation. Then we have seen there is a possibility of getting tertiary carbocation, so that's why we have did hydride shift over here. And then nucleophilic attack, like Cl negative attack on the this carbocation, we have got the major product. Okay, so this is the first question that we have solved. I hope you have understood this question. Okay, and the next question, you just try to solve this by your own. So let's try to solve the second question first. Sorry, yeah, let's try to solve this question first. Try it by your own and then watch the video. Okay, first this one is like this is famous Niemann reaction, which is Riemann-Tiemann reaction. Okay, Riemann-Tiemann reaction. And here what happens when we take a phenol and in the presence of this particular reagent, CHCl3, and in the presence of base, here they have given NaOH, you can take KOH also, and then hydrolysis. What happens? The CH4 group will get substituted over ortho and para positions of ortho and para positions with respect to this OH group. First we'll get this like ortho product, and then we'll get one where the CH4 is get substituted over here. Okay, so which is major? Just try to think. This is ortho product and this is para, and the name of this compound is salicylaldehyde. Okay, let me just change the color. This is salicylaldehyde, and here this one is major. Ortho product is major. Why? Why? Because there is an intramolecular hydrogen bonding is possible over here. This compound is major than this para. Okay, generally para products will be major rather than ortho because of less steric hindrance in para. But here in this case, there is a possibility of there is an hydrogen bonding because of that. Because of that reason, ortho is major. Okay, so here this option is R. So this is our B. Okay, product B. And here one more reaction that they have given is this phenol in the presence of Br2CS2, and they have given the temperature. See the two things here. If they give, in case of here they have given CS2, which is a non-polar solvent. Okay, so in this case what happens means we'll get the ortho and para products separately. So we'll get these products over here. So bromine will get substituted over ortho position once, and we'll get the para product OHBr. So here this is para and this is ortho. So obviously this para product is major over here because why? Because of less steric because of less steric hindrance, this will be major. As there is no possibility of forming any hydrogen bonding over here, as that occurred in this particular case. So this is major. Okay, and yeah. So this is our product. This is our product A. Okay. So here one more point I just want to tell you, which is when we treat this phenol with Br2 in the presence of water, like any polar solvents like water, then we'll get what happens in polar solvent means this water helps to generate the strong electrophile Br positive. So as we know this is strong activating group. So as we know that OH is strong activating group which activates the benzene ring. Okay. So bromine, what happens? It will substitute over all the three positions of all like ortho and para, and then we'll get this product Br. So we'll get this product. This Br will get substituted over ortho, all ortho and para positions. Okay. So I hope you have understood the difference between when they give different solvents, then also we'll get a different products, right? They might ask this question also in your examination, who knows, right? So you need to know when if they give non-polar solvent, we'll get two products, one is ortho and one is para, and para will be the major one. And when if they give polar solvents like water, the bromine gets substituted over all the ortho and para positions, okay? Because this C OH is electron donating group. Generally, electron donating groups are ortho para directing group. That's why it is not getting substituted over meta position. That I hope you already knew that. I hope you already know that thing. Okay, so you come to this chapter means you would have completed all the basics of those things, and you just need to know what exactly these electron donating groups. Why it is like what I'm doing here. Why am I even substituting over only ortho and para? Why can't I substitute over here on meta position? If you want to know all these things, you need to get a no conceptual knowledge from GOC. So I'll make a video if you want. I maybe by that time I would have created a videos on GOC also. So yeah, just don't worry. You just prepare well, and if you couldn't able to understand any concept anywhere, you just let me know in the comment section. I'll try to make videos on that particular topic. Okay. So yeah, I hope this question is fine for you. I hope you have understood. So the option product A, major product A is this, and the major product B is this. So this is a Neyman reaction, Riemann-Tiemann reaction. Okay. So that's why what you'll do, you just try to write the all the Neyman reaction in one A4 size sheet, and just try to like what you'll say. Just try to no, I'm not saying to mug up and all. Just see daily. Then you can have that idea. So if they give phenol and if they give this type of reagent, we'll get these products. So this is a recommendation. That's how your mind works, right? So yeah, that's it. Uh, Let's solve one more question. So let's see one more question. So again, just try to solve by your own. Sorry. So again, just try to solve by your own, and then we'll solve one by one. Okay. So let's try to solve this question. I hope you have paused this video and tried by your own, and then you are watching this video solution. Okay. Okay, fine. So here this is CN, and here it is OCH3. Okay, let me write the CN like this. C triple bond N. Okay. Sorry. This is C triple bond N. And here they have given Grignard reagent, which is one of the famous reagent that we'll keep on using in organic chemistry, right? So yeah, first what happens? It acts like a nucleophile and it will attack on this carbon. Why? Because between carbon and nitrogen there is an electronegativity difference, right? Nitrogen is more electronegative as compared to carbon, so carbon get partial positive charge and nitrogen get partial negative charge. That's why this negative charge, like this, act like a nucleophile and it will attack on this particular carbon, and this one of the bond shift towards nitrogen, and here we'll get this product. Okay, and here we'll get this. Here it is C double bond N negative MgBr, and then here it is C6H5. Okay, this group remains same as it is. And then in the next step they have given like hydrolysis also. Like when they do hydrolysis, generally first it captures this nitrogen, captures one of the one of the hydrogen, and it forms this. Okay, C6H5. This is also one of the benzene. You can write it like this: C double bond. It forms NH, and here it is OCH3. And again, like water means they have given like if you give water, what happens? You just break this bond between between carbon and nitrogen. You just break this bond and give to H2 to this nitrogen, and oxygen to this carbon. So finally, we'll get this product. C double C6H5. This is a double bond O, and here it is this. So we have got this carbonyl compound, right? So yeah, this is the final product, which is major product X. So I hope you have understood. This is a short trick that you can use if you like whenever there is a thing, like whenever there is a cyanide group, and if it reacts with a Grignard reagent, generally nucleophilic addition takes place. Here this act like a nucleophile and we are adding over here. That's why it is nucleophilic addition reaction. Okay, this is not substitution. We are not substituting anything, we are just adding over here, right? So that's why it is nucleophilic addition reaction, and this bond shift towards here, and when we do hydrolysis, just break this bond and add oxygen to the carbon. Finally we'll get the carbonyl compound. And also further, if you want to do, we can do so many reactions to this thing only, this compound only. Like we can just again we can use one more mole of this Grignard reagent and we can do so many reactions, but they have asked the major product. Here we have already got it, right? So yeah, that's it for this particular question. And yeah, next let's move to the next question. And next question is a simple. They have, see, this is already simple because they have already given the products also. You just need to know which is major, compound A or compound B. So what is the name of this reaction? This is simply acid catalyzed hydration. Acid catalyzed hydration. Okay, so what we are doing over here, let me try to tell you the mechanism how we got these products from this particular substrate or reactant. Okay, so this is benzene and here we have this group. Okay, here first they have given concentrated H2SO4, means H plus is there, right? So whenever that, I have told you this mechanism is super easy, and you will once you understand the basic mechanisms, like whenever there is OH and if they give any acidic conditions, then protonation occurs for sure. Okay, maybe in few cases it might not, maybe there might be different situation, but here the protonation occurs. Okay, means protonation means what? It will just abstract the hydrogen. Okay, and it will form this OH2 positive. Just don't worry, I'll draw one more carbon here, I didn't forget. Okay, and here what happens then? Water leaves, has a living group. Water is a good living group, so it leaves, and then we'll get a carbocation over here. Okay, and what happens in the next step? Like generally, it is an even mechanism. Okay, so as they have given heat, then generally they'll give a acidic condition and they'll mention heat so that you'll understand like it is an elimination reaction from beta hydrogen. Like with respect to this carbocation, this is alpha carbon and this is beta carbon. From beta carbon, hydrogen will be left, like conjugate base of this is what? H2, HSO4 negative. This will abstract this hydrogen and this bond shift towards here, and in order to stabilize the carbocation. Okay, and here it will form this, and I have drawn like this, but there is also one more possibility that they have drawn is this. Okay, you can see it is showing two geometrical isomers, right? This is trans and this is cis. Why? Because these groups are opposite side, and here the groups are on the same side. Generally, trans product will be more stable rather than cis products because the groups are on the opposite side. So less steric hindrance will be there in trans. Less steric hindrance. Because of this, just don't mind my handwriting. Okay, so option is yeah, this one compound A will be the major product because this is trans product and this is cis product. Trans is more will be major product. I hope you have understood the mechanism of this acid catalyzed hydration. Again, it is just an elimination reaction. First protonation occurs and then deprotonation occurs. Protonation, and this we will study in alkenes chapters also. Preparation of alkenes from alcohols. See how they are repeating. We have already studied in alkenes chapter, and also this is there in the alcohols chapter. This organic chemistry is like you can say web series, episode by episode. If you see first episode, then only you can able to understand the second one, right? So that's how this works. Like if you didn't understand the GOC part, I'm not hyping that much GOC part, but you just need to know basics, at least basics. If you know, you can just manage the things. Okay, if you understand the basics first, like inductive effect, mesomeric effect, and resonance, and hyperconjugation, and acidity, basicity. These are the basic things that you need to know. Okay, from GOC. If you know these things, and also geometrical isomerisms, that like trans and cis compounds, if you know these things, it will be easy. See, here we are not just solving from this particular topic, we are applying the concepts from different chapters, right? So just don't compare like this chapter is more weightage, so I'll study this chapter and I'll skip remaining. It's not like other subject. So there are two options for you. Read all the chapters from zeros to amines, or else just forget about organic chemistry. Okay, I'm not telling you to forget, but yeah, the main thing that I wanted to tell you is that you need a sequence. First, start with GOC and then hydrocarbons, and then after that, alkyl halides, then this phenols like ethers, alcohols, and then aldehydes, carboxylic acids, then amines. This is how you need to follow a sequence. Okay, so this question also easy, right? So I hope you have understood. Let's solve one more question. And yeah, this is some sort of interesting. Okay, this is some sort of interesting that you I should, yeah. Sometimes it's so irritating, like if it moves again and again. Okay, but don't mind. OH. Here double bond is there, and here double bond OCH3. Okay, and here they have given concentrated HBr. What happens first? Again protonation. these many times I'm doing protonation means you would have just got habituated. Like whenever there is a OH and if they gave an acidic medium, then protonation occurs for sure. Okay. Here this two OCH3 double bond. Here it is OH2 positive. Here the in the next step what happens? See here the thing is important. Here what happens means this double bond is there, right? So this double bond shift towards here and it will form a double bond over here and this will leave as a water. So here we'll get this one double bond O OCH3 and here it will form a double bond, here CH3 will be there, and as this given its electron to this carbon, so here we'll get a positive charge. Okay, and this anyway water has lived as a living group. And in the next step what happens, we have Br negative, so this act like a nucleophile and it will attack on the carbocation. Okay, finally we'll get this product. This is double bond O OCH3. Here it is a double bond and here it will be bromine. So I hope you have understood this. It might be confusing over here. This step is somewhat little bit confusing, but you might have done like this directly, Hana. So Br negative will attack over here and this will leave. But this is wrong. You might get a product, but we will get a minor product. Okay, this is the major. So you might get a product over here, but that will be the minor, and this is the major product. So option B is this is correct. Okay, this is correct option. Okay, I hope you have understood. You didn't get confused over here. Okay, yeah. Let's move to the next question. This is also yeah yeah. Where is this? So this is also acid catalyzed dehydration only. Acid catalyzed. We have solved, right? We are solving so many questions based on the same topic so that you will understand the topic and based on this topic, if they gave questions, then you can be able to solve it easily. This is dehydration. Okay. So the same thing. First, do the protonation. So here the given this. First, do the protonation. H plus is there. So this will abstract this hydrogen and it will form what it will form OH2 positive. Then in the next step it will leave as a leaving group. Water will be removed and it will form a carbocation. Okay. And in the next step what happens? See here this is a what is this? I mean, is it primary, secondary or tertiary carbocation? This is actually this carbocation is connected to only one carbon, so this is primary, right? So if you just shift this hydrogen over here from here, like let me change the color. Yeah, if you do the hydride shift, okay, we'll get the carbocation over this carbon. Okay, then this carbon is tertiary, right? Because it attached to three different groups. So we'll get here we are doing hydride shift. So remember, whenever there is a possibility of formation of carbocation, there you need to check. Do we get any like a tertiary carbocation or phenolic or allylic? Like, is there any possible way to get the more stable carbocation? That's how you need to check. Here, what we'll get? Here, this hydrogen move to this methyl group, and here we'll get a positive charge. Okay, and this is the positive charge. Okay, let me rub and write it clearly. Oof, again. So now what happens? In the next step, they have given heat also. So it does elimination reaction. So this H is there, right? So its conjugate base is what H2PO2 PO4 negative. It will abstract this hydrogen and we'll get this alkane over here. Okay. And in the next step, what happens? This is one of the name reaction again. This is one of the name reaction, which is hydroboration oxidation. So in hydroboration oxidation, what happens? It is simply addition of water only. Okay, addition of water across this double bond through anti-Markovnikov rule. Okay, what is Markovnikov rule exactly? Let me explain you with this particular example so that you'll understand it easily. So let's say for example we want to add water across this. Okay, so what we'll do? We'll add the hydrogen to the carbon which is having more number of hydrogens. Okay, or else you can say this is the simplest way you can remember. According to Markovnikov rule, if you are adding water means just add the hydrogen to the carbon which is having more number of hydrogens. Here the carbon is having only one hydrogen. Here the carbon is having two hydrogens. So we will add the hydrogen over here and OH over here. So we'll get this product CH3 CHOH CH3. Okay, or else you can also say it like this. Add the OH negative, OH negative to the more substituted carbon. Here more substituted carbon is what? Across this double bond, these two carbons only you need to see. Don't go to this carbon. Okay, we are adding OH and H across this double bond. So add the OH negative to the carbon which is more substituted. This carbon is more substituted obviously than this one. So OH will be added on this and H will be added on this. First thing what I have told you, add the hydrogen to the carbon which is having more number of hydrogens. But that is the Markovnikov rule. Okay, don't get confused over here. And anti-Markovnikov rule means just opposite of this. So here what we'll get? Here this is the across the double bond is these two carbons are there, so you need to focus on these two carbons which is having we need to, or else let's say here we have added OH negative to the more substituted carbon. Here we need to add OH to the less substituted carbon which is less substituted, this one, right? Rather than this carbon is more substituted. So according to anti-Markovnikov rule we'll get this OH. Okay, I hope you have understood this. What exactly Markovnikov rule, what exactly anti-Markovnikov rule. We have added this OH negative to the less substituted carbon. Okay, yeah. So see, all these questions are very simple, but you need to understand once. If you understand, see, how many times we have did this mechanism till now? See, all are protonation only. So if you watch this video once, when if a question comes based on this topic, you can easily solve that particular question, right? So I think it will become a long video. I hope you have understood all these. How many questions you have solved? So 6 questions we have solved till now. So you just you just watch this video and in 2x speed, try to watch it in 2x speed so that you can save your time also. And this will be the part 1 and I'll be solving remaining questions in my next video which is part 2. Okay, I hope you have understood till now. Okay, yeah, that's it for this particular video. And just one thing that you can do for me is that okay. So yeah, that you can do a small favor. Okay, that's it for this particular video. And if you have any doubts, I am here to help you out. So you just don't hesitate to ask me the doubts, because it's not even on offline classes you are asking me, not offline, right? It's just online. Just keep one comment in the comment box. Just keep one message in the comment box. I'll try to give a reply to you. Okay, and I'll make a video on that particular topic if you have any doubts. Okay, that's it for this particular video. And if you want videos like this, I need some sort of motivation. I need some sort of push, right? So if you people, if I think that these videos are helping you people, then only I can able to create even more videos. So, and for that what you need to do. Okay, thank you and take care of yourself and be kind. Bye.